Okay, here's three more problems. Let's look at them pretty quick. And all of these are basically the same. We're going to find the probability of hitting one of the shaded squares with a dart. What's the probability? Well, in order to find the probability, geometric probability, we have to take the total area, find out what the total area is, and find out what the area of the shaded part is, and then go from there. Or sometimes we can get fairly lucky and do it pretty simple. On this one right here, what I'd recommend doing is that we look and see how many squares we've got total. Okay, we can do that by counting down and across. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, and 8. So we've got an 8 by 8, which equals 64 squares. All right? How many of them are shaded? Well, let's count them. Let's use red on this. I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Ooh, let's clean this off. 11, 12, 13, 14, 15, 16, 17. So I have 17 squares, 17 shaded squares. What's the probability of me hitting that? 17 divided by 64 equals, I can't quite do that one in my head, so let's do 17, 64 equals 0.266. Okay, 0.266. Make that into a probability. We're looking at our probability being 26.6%. Okay, in this case, all we had to do was simply count the squares that we had because all those squares are the same size. Okay, now let's look at another one that's going to cause us to have to do some work. Find the probability of hitting the shaded area with a dart. We're given a square, a circle that is circumscribed by a square. Okay, so we have to find the total area and then the area of the circle, and we want to hit the shaded area, so we're going to be looking at the area of the square minus the area of the circle to come up with the shaded area. Okay, and then what we're going to do is we're going to divide that by the area of the square to come up with our probability. Okay? So, number one, we need size. For the area of a square, we need what? Equals s squared. Well, s equals 12. For the area of the circle, we need pi r squared. Well, r equals what? What's r equal? R equals 12 divided by 2 equals 6. Okay, if we do this one, we get 12 squared equals 144. We do this one, we get pi times 36. Alright, what's pi times 36 equal? Let's find out. $113.1. Okay? Now let's go back up here to this equation that we set up. We've got 144 minus 113.1 all divided by 144. Okay? So let's do that. We've got 30.9 divided by 144. Move that over. We've got 30.9 divided by 144 equals 0.215 equals 21. Problem's right tonight. 21.5%. Okay? So the chances of me hitting the shaded part would be 21.5%. Let's go over again exactly how we did this. We're given that each side of that square is 12. From that, we determined that the area of the square is, wow, that's just side squared, it's 144. What is the radius of that circle? Well, it would be half of the side, and that side is the diameter of that thing. So we're going to take 12 divided by 2, and we're going to get 6. What's our area of a circle? Pi r squared. We get 113.1. Now, to find the shaded area, we take the square, we subtract the circle from it, and we divide by the square to find that probability. There's that. We do that. We come up with 21.5 or 0.215, which is a probability of 21.5%. All right? Don't forget to divide by the total area. To get that probability. Now, here's one that's a little different. Need to work with it just a little bit and find out what's going on. We want to find out what probability of hitting the shaded area. Well, let's label this as 3 different circles. We've got circle A here. Ooh, boy, that's dirty, isn't it? Circle A right there. We've got circle B goes to here, and circle C goes to there. Well, the radius of A equals what? 2. What's the radius of B? 2 plus 5 is 7. What's the radius of C? Equals 7 times plus 1 is 8. What we're going to have to do is we're going to have to find the area of all of that. What's our total area? Well, that is the area of circle C equals pi times 8 squared. Got it? Well, what's the area of our shaded part? This is our total. Shaded. Well, that's the area of circle B minus area of circle A, isn't it? So we want area of circle B minus area of A. Area of B equals pi times 7 squared equals, let's just go ahead and get it done, pi times 49 equals 153.94. Let's go ahead and get this one. Pi times 64 equals 201.01. Now 201.1, let's put 1. Now what is our area of A? Pi times 2 squared equals 4 times pi, 12.57. So, we've got to come up with, and we've already said, we're looking at the area of circle B minus the area of circle A divided by the area of circle C. You ready? Area of circle B, 153.94 minus area of circle A, 12.57, all divided by the total area, which is 201.1. Find out what that equals. 153.94, subtract 12.57, divide all that by 201.1. We get 0.703, and that equals 70.3%. Okay? Need to look at that. Let's review it one more time. We have 3 circles. What is the probability of us hitting between the inside circle and the outside circle in getting that shaded part. We've got to know the radius of all those circles, and then we have to find the area of all of them, and then we need to take, we want B, we want the area of B without A in it. So we're going to have to take the area of circle B minus area of circle A and divide it by the area of circle C because that's the total, and then we will come up with a probability for that. So all we do is put them into our equations and go. So all we're doing is calculating the area and go, oh, what's the probability of us hitting that? And then we're checking the probability. Got a couple more we want to do, and then we'll be through with this whole chapter on area.